that's what I was referencing. You know, they play Klingon Boggle, or was it? Yeah, that's it, right? Klingon Boggle. They're just making up words. Actually, I think Klingon is actually a documented language.
They have classes on it.
Yeah, I mean, I'm pretty sure the Star Wars geekdom has created the Klingon language and documented the language. So it would potentially be, that would be pretty funny to go to some school and a class is being taught in Klingon. All right, so let's. So what does it mean for what does the keyword static mean as it relates to methods? It means that the class owns the method, something like that. All right, and how do you call a class method? How do you call a static method? Go ahead.
Class name, method name.
Yep. So using the name of the class in which the method was defined, or as he said, class name dot method name and then params. Something in that ballpark is a reasonable answer. All right, so the inverse of this guy is if we don't see the static keyword in front of a method, what does that mean? If we see the static keyword, it means it's a class method. It's owned by the class. If we don't see the static keyword, what does that mean for us? Go ahead.
It's owned by an instance of the class.
Owned by an instance of the class. And how do we call instance methods?
Instance name, method name.
Yep, so using an instance of the class in which the method was defined. All right, good. So let's go back here. This is us, right? All right, so homework assignment was to write reverse string. Oh yeah, here it is. Display in reverse. So this method should display on a single line the input string in reverse. So hello to OLLEH. All right, so the couple of things we looked at the end of class last time, or the second half of class last time, was kind of our stock for loop that goes through a string, right? And we kind of disconnected the idea of the loop to the string. We just happened to be using that counting variable to reference indices in the string. The loop and the string actually have nothing to do with each other by default. We've been practicing with a couple of built-in methods that the string class owns. Char_at, which gives us a character at a particular position in the string class, as well as length, which tells us how long a string is. We dealt with the example where if I ask you, if we're looking at that function definition there, and I ask you what the length of s is, correct answer is s.length, right? The string itself, the instance of the string, can report its length to me. That's the whole purpose of writing a method, is we write it once and we can use it multiple times, so we have to write it generically. All right, so in order to solve this problem, we're going to do our stock loop that goes through every character in the string, but we're going to reverse it so that we start at the end, the last legal position in the string, and go all the way to the beginning, including bucket 0 of the string. So what is the last legal position in S? S.length minus 1 is the last legal position in S. So we'd like to have our counter and our loop start off at that dude, right? So for int I is equal to S.length minus 1. That's the last legal position in S. Because if its length is 5, buckets are 0 to 4. Okay? We're going to keep going, Boolean expression, as long as I is greater than or equal to 0. You know what I should have added to the quiz for extra credit? Who's currently leading the Masters tournament and what's their score? No golf fans in here? Does anybody know the answer to that?
Speed.
Speed. Is that a guess or you knew?
I knew.
Okay. Current score?
That was a guess. It was not good. Down 3.
Better than that.
What are you doing?
6 under.
600?
Day one, 600. Pretty legit. Scoring average was 2 over. Yeah, he's 8 ahead of the field. It's pretty. Yeah, it was a good day. See if he can hold it together today. So only one person would have gotten the quiz right. That's it. I mean, isn't golf kind of the same as like Super Bowl? It's not the same. Not the same thing. Well, the Masters is like the golf Super Bowl. It's like the same. Everybody in here has heard of the Masters golf tournament. You might not know anything about it, but you've heard of it. It's like one of like 2 tournaments you've heard of. Well, it's going on right now, so if you come by my office, you'll hear it streaming. I still have it streaming right now, actually, so I can rewind and not lose any footage. All right, so we'll start off at the last legal position in the string. Keep going as long as I is greater than or equal to 0, making sure that we subtract 1 from I each time. So if the length of the string was 5, we'll start off at 4, then go to 3, then go to 2, then go to 1, then go to 0, including the 0. That's why we said greater than or equal to, because bucket 0 is a legal position in there. All right, and if we were to do a system.out.println, for example, s.char@i like this, this is going to give us almost the correct answer. Okay, this is going to show us our string in reverse 1 character at a time. Okay, so not quite what we were looking for, but close. So let's just look at this. So this loop will go take I on a voyage between s.length minus 1 all the way up to and including 0, subtracting 1 from itself each time through. And what are we going to do each time? We're going to extract the character at position I in S. Now, question. Based on the way I'm calling char@, is char@ a static method or a non-static method? I heard, I think, 1.5 whispers.
Non-static?
Non-static method. How do you know?
It's being called by S.
Being called by S, which is an instance of the string class. It's actually a variable which contains an instance of the string class, but same diff in the real world. We're more just kind of being nitpicky with that. But yeah, so this guy, if we were to go look at the documentation, which I think we did last time, right, we would not find the keyword static in front of it. Okay, and this is the proof. This is where we're actually calling upon that method as opposed to looking at the method definition. Okay, those two guys match up. So the definition would either have static or not have static. Calling it would either be called with the class name or called with an instance of the class in which it was defined. Okay, you would never see static when you're actually calling it. So those are the 2 different sides of the same coin. All right, so we'll go ahead and call this guy. Now, this method has static in front of it, so that means it's owned by the class. We need to call this using the name of the class in which this method was defined. This method was defined inside of a class called driver. So we'll go ahead and we'll just come up here. We'll say driver.display in reverse, and let's pass it S2 for elephant. And this is going to show us, actually let's pass it S so we can test it against what our current thing says. This is going to print out hello in reverse, but 1 character per line. So it would be O, then L, then L, then E, then H. Go ahead and run that. All right, so the correct sequence of characters, but not really displayed the way we wanted it displayed for our homework assignment. So the other thing we talked about last class was string concatenation, a topic we've already discovered and dealt with in Alice, but now we look at Java's version of this. So Java's operator for string concatenation is the plus sign. All right, and Java intelligently decides whether or not you intend to add numbers or whether you intend to glue strings together based on what things are on either side of the plus sign. If there's at least 1 string involved on either the left or the right-hand side of the plus sign, Java treats the plus operator as the concatenation operator. If there's not at least 1 string involved, it treats it as the addition operator, so hopefully it's things that can be added. Otherwise, Java's going to scream at you and say this is not a number and addition's doesn't make any sense. So with this in mind, we're going to go ahead and we're going to build up our answer just like we did in display with spaces. So we're going to create a string. You can call it whatever you want. We just happen to call it answer, and we'll start it off as the empty string. So the empty string gives us an empty base to build on top of. Each time through, rather than printing out a character, we're going to say answer is equal to answer concatenated with s dot char add I. All right, so we'll go ahead and build that guy up. And then as soon as that loop is done, we can go ahead and say system.out.println answer. Okay, run that, and now we get the response that we were looking for the homework. All right, so start off with an empty variable name answer. It's the empty string. Go through every character in our string, concatenate it onto our running total, if you will, and ultimately, once the loop is done, print out the current value of answer. Make sense? Good.
Wouldn't you achieve the same result with just saying system.out.print?
You would. Yeah, if you said system.out.print, you would get the same result. But if you then said system.out.print or println,
No, without even answer, just printing I each time.
oh, you would. You would. Yeah. Let me just show this first, since this is what I thought you were asking. So print keeps you on the same line. All right, so here I just tacked an LOL onto the end of this thing because print doesn't kick you down a line, doesn't press the return key, if you will. So what he was suggesting is rather than use concatenation to build this up, we could actually, I'll just write it again, do a system.out.print s.charat I, which prints it back to back to back, and then maybe do a final println on the empty string to kick it down a line so that you don't, if you go to someplace else in your program, you're not dealing with, you're not still on the previous line because you never kicked it down. So this will give us the same output because we printed each of those characters in the line rather than do a println. Make sense? All right. Now, let's go ahead and modify our function here. So instead of display in reverse, let's just call this guy reverse string. And we'll actually have this guy return a string. So it's going to actually return our original string in reverse as opposed to print it. So returning and displaying are two very different things. It didn't matter what we named the method, but I just named it something appropriate for what we're doing. So in this case, we'll go ahead and we'll say answer is equal to answer concatenated with s.charat I. And then in the end, we're going to return answer. All right, so reverse string goes through and it builds up our parameter value s in reverse inside of a variable called answer, ultimately returning answer. Make sense? So we'll come back up here and we'll do driver dot reverse string. We'll give it string s2. All right. What will the output of this program be? Trick question, FYI. Remember, all programs begin and end with main. So what does main say we should do? Main says define one variable, define another variable, call the reverse string method, passing it one of your variables. In this case, we passed it elephant. Elephant comes into reverse string. We build up elephant in reverse inside of answer, ultimately returning answer. So this guy boils down to answer. What are we doing with it? Nothing. We're not doing anything with answer. So this will boil down to elephant in reverse, and we're just letting it disappear, disintegrate. Okay, we have a couple of options. We could store it somewhere, or we can just print it directly. So I can say system.out.println like this. So we can print the result of calling reverse string on S2. So this will give us elephant in reverse. All right. Now, there's nothing wrong with doing this, but the issue here is if we need elephant in reverse later, we have not preserved that value anywhere. It got passed into println, it did its thing, it displayed to the screen, and then we lost it forever. So if we're going to need it again to do something, we're going to have to store it someplace. So we might decide to say string result is equal to that. Then we can print out result, showing our string in reverse. But we still have access to that string. We've stored it inside of a variable called result. So now if we want, we can go in and we can call our display with spaces, giving it result, and we should get elephant in reverse with spaces displayed to the screen. Okay, makes sense? Stringing all these things together, pun intended. All right. So, do people say that anymore, pun intended, or is that like just an old person thing? Is that like a thing? Because there's all these new phrases that I'm not familiar with. Yeah, you used one a couple weeks ago. You said the Guatemalan prison guy was chill. I had to go look that up. What's up? No, I understood what it was, but it's not like a part of what I would usually say. I've added it now. I just use it all of the time. Yeah, for all sorts of different things. Well, probably a bunch of them that don't make any sense. Yeah. But it's cool, right? That's like what the cool kids say. They say chill. I don't think anybody was chilling in Guatemala. It wasn't like 1,000 degrees. Yeah. So it was hot, right? We had my wife and I were going to Israel in June. We were talking to the tour guide last night, and he said it's going to be like 105 degrees or something like that there. But we're visiting all these churches, but you're not allowed to wear shorts. That seems counterintuitive. Like, doesn't it seem like if it's that hot, you should wear less clothes? We built these churches in the wrong part of the world, is what happened.
Some like tights to make sure they don't let me rule anymore.
Hey, that's right. Like, look, you said you can't show anything above the knees and no shoulders. So I went full body spandex. Everybody, get your the mental image there. What's up?
One of those morph suits.
Morph suits?
Yeah.
Is that kind of like the spandex thing? Is that the same thing?
Yeah, it's like a full costume, like around Halloween.
Yeah.
Zipper in the back, covers your whole body.
Okay, so not just it's the head too.
It's the head
so everything's in spandex.
Everything's in spandex.
Okay, but it's got like built-in muscles in it because it's probably like a superhero thing, or is that not the case?
That's not a thing.
It's just a weird costume. Why do you know about this?
I don't know. It's pretty popular.
That's chill. So I don't think that was the right use of it, right? No, I'm pretty sure. Yeah, I mean, I think chill would be like, somebody punches you in the face and you act like nothing happened and you're like, oh, he was chill. Right? That's legit. Yep, see? Nailed it.
I love when I'm rewatching these videos going back to moments like these where we're just like not talking about anything to do with programming.
Well, that's the best part. We got to introduce humor, otherwise you get bored with this stuff. Right? It's like, oh yeah, that joke came right after we learned topic X. See? All right, so you're learning stuff and I'm learning about chill. So it's a two-way street. Okay, so we know about char@, we know about length. So let's introduce some other functions. indexOf. All right, so this is again inside the string class. So the indexOf method would have a definition like this: int indexOf char c. There's actually a version of it that takes a string as well, but this is the only one I'm introducing to you, is the one that takes on a character. So indexOf char c, and this guy returns the position in the calling string where c is first found, or -1 if it was not found. All right. Now, first of all, I'm going to put that in bold and make that one thing bigger. That is a very, very, very important fact, okay, for problem solving. It might seem fairly benign as we introduce it, like, okay, well, it returns -1 if it's not found, but I promise you, very shortly in a homework assignment, that little fact is going to be very, very handy. All right, so kind of remember that's the case. All right, so class method or instance method? This is the variable. This is the method definition we're looking at here. Is that a class method or is it an instance method? Instance method. How do you know?
It's called by an instance. It's not called by the.
Well, I'm not calling it with anything. This is the definition. So how do you know that's a instance method by the definition? You're telling me how you would call it. I'm just showing you the definition. How do you know this is an instance method by the method definition here? No static. Yep. So because we don't see a static out front, we've now identified this guy as an instance method. Therefore, the way we would call it is by using an instance of the class in which it was defined, and this guy is defined inside of the string class. All right? And so the calling string is the string we called this guy with. The instance of the string class we called this guy with. All right, so let's go back in here. We'll just delete a couple of these things. So for instance, if I say system.out.println s2.indexOf, let's start with a P. The character P. This is bucket 0, 1, 2, 3. So this should return a 3, the appearance of the first character P in the string. So indexOf should give us a 3 for that guy. And run it. There's our 3. All right, it was able to search through there and find the P for us. Similarly, if we say E, it's going to give us the position of the first occurrence. So the first occurrence of E is bucket 0, not bucket 2. All right, so this is going to boil down to 0 for an E. Okay? And if we have it take in a Z, which is not found in that string, it should give us a -1. Make sense? All right. So we understand how indexOf works. All right. So before we do anything else, oh, go ahead.
What would you do for the second?
Well, in this particular case, there actually is another function called lastIndexOf, but that will return the position of the very last index of a character we're looking for. In this case, we happen to know the second E is the last index, but that tool isn't necessarily going to be useful if you just wanted the second index. So you could write a function that goes through and finds the second occurrence of something, or -1 if it wasn't in existence, but we don't have a built-in tool for that. All right, so now we know that Java has this built-in function, but before we can, in good conscience, use that function, we probably should write our own version of indexOf to really appreciate how it's working, right? So we're going to write our own function, own method, called indexOf, that's going to take a char as a parameter as well as a string, all right, because we're going to have both things come in, because we didn't write this string class, so we don't have the ability to access the calling string. So we'll have to have it provided to us. So I'll go ahead and write the header for this. So static int indexOf string s char c, and this guy should return the first occurrence in s where c is found, or -1 if it was not found. We can't use the strings indexOf method, because that would just be poor form, right? Because a legitimate solution to this problem in terms of accuracy would be just to return s dot indexOf c. And we can say we're done. That gives us the correct answer. We're not allowed to do that. We're going to pretend like the strings indexOf method doesn't exist for a moment, and we're going to write that logic ourselves. All right? So, what we're effectively doing here is we are searching through every character of our string, looking for the first occurrence of a particular char. As soon as we find it, we're going to return the position we're currently looking at. If we never find it, we're going to return a -1. Okay, so we're having to piece together several of the things we've done up to this point. We're going through every character in a string, so that's going to be our for loop, and that's going to be our char at method, looking at a particular character. We're going to be asking questions about each character, conditional. So if the current character we're looking at is the character we were looking for, go ahead and return our current position. That's probably going to be our variable I from our for loop. If we survive the for loop and never return anything, at that point in time we know it wasn't found, so we'll return a -1. All right, so we're piecing several things together here. So we'll go ahead and we'll write our stock for loop for int I is equal to 0, I is less than s dot length. That's the number of characters in the string that was passed to this guy. I is equal to I plus 1. Remind me, as soon as we're done with this, I'm going to introduce the plus plus operator. That way I don't have to keep typing this. Okay. Now we're going to ask the question. So each time through, we'll extract the current characters. That's s dot char at I. So this is the current character we're looking at. And we want to ask a question around that guy. So we're going to say, if that character is equivalent, double equal sign, to the character we're looking for. That is the character stored within the parameter named C. If that's a true statement, if we're looking at a match, go ahead and we want to return the integer that is the index in our string that we found the answer. That is I. So we'll return I. Otherwise, if this is false, we'll hit the end of the for loop, spin back up, and keep cooking. Check the next character. All right. If we survived, we're still kicking. That means we went through every single. It's still chilling? Is it still chilling? Not still chilling. Probably not still chilling. Still chilling. All right. If we got through the entire for loop and never found a match, then we would be sitting here and we'll just return a -1. We never found the match. All right, so we'll go ahead and do our catch-all -1. Now, an interesting thing here, let me leave this off for a second. We have advertised to Java that this method will return an int. All right, Java requires us to return that integer. Since a for loop is a pre-check loop, there is no guarantee we will ever execute the body of that loop. Therefore, there is no guarantee that we'll ever get to this if statement. And if statements, there's no guarantee we'll ever get inside of that if statement, because we only get inside the if statement in the event that we have that it's true. And there's no corresponding else to this, so we don't have the otherwise. So basically, this return is behind one potentially locked door inside of a room with another potentially locked door. From Java's perspective, there is absolutely no guarantee that this method, as currently written, ever returns a value. There are some situations where it would return a value, but we have advertised to Java that we will always return an int. Make sense? So Java's kind of ticked off at us right now, hence the red underlining. It's going to say this guy must return a value. So a method must return a result of type int. So that's where we put in our return -1 down here. This is our catch-all. Remember, return makes a method immediately end. Therefore, if we get inside this for loop and we get inside this if statement and we happen to return I here, that method just got killed off. We won't loop through again. We'll never have the opportunity to get back out here. The method ended. Make sense? All right. So here is indexOf. We'll go ahead and test it. So we got PEZ, that was what, 3, 0, -1. So let's test those exact same things on our function. Driver.indexOf, we'll pass it S2, and we'll pass it P. And we'll print out the result. We'll pass it E. We'll pass it Z. Three zero -1, 3 0 -1. All right, so now that we've exhaustively tested our indexOf with those three checks, we can say that it is identical to Java's indexOf. So kind of an important thing here is we can look at this and see that this was not that difficult to write. indexOf is a convenience method, helps us solve a problem, blah, blah, blah. But at the end of the day, this wasn't rocket science to write indexOf. So take that into consideration when you're trying to solve a problem. For example, you asked a few minutes ago, what if we wanted to get the second E? Now, there may be a tool built into Java to solve a particular problem you want to solve. But if you don't necessarily know that it's built in, and it's not important enough, you're like, well, I could just write it myself in a couple of minutes. Why go on a wild goose chase, looking through Java's documentation, trying to find a built-in something or other that solves a problem that you could just solve yourself real quick, quickly. Over time, you might, add to your vocabulary of things that Java has built into it. Some of those tools that you might otherwise look someplace else for. But at the end of the day, writing something like this wasn't a big deal. Okay? So punchline there is when you're trying to solve your problems, don't immediately hit Google typing in verbatim the homework assignment. Show me solution to the sentence, something like that. Although that might work for some common assignments, but in any case, sometimes it's just going to be easier to write it yourself. So don't spend a whole lot of time hunting for a tool when you can build your own wrench. All right, questions about that one? Okay. So for starters here, so now that we wrote this ourselves and we appreciate the indexOf function, we can use it now. We can use the strings built-in one. We don't have to use our version of it. So I'm going to write a couple of. Oh, thank you. Let me quickly write a couple of starting points here for us because this is going to be our homework assignment. So static string remove vowels. This guy removes all of the vowels from the string parameter and returns a new string with all of the vowels removed. Really, that's kind of a redundant statement. This just returns this new string with all the vowels removed from the parameter. All right, so that's what remove vowels will do. And for right now, I'm just going to throw in a return empty string, so this guy's happy. We're also going to have a remove consonants. And lastly, remove digits. So your homework assignment for Monday is to write these three methods. I think you will find indexOf extremely helpful in solving this problem. And once you solve one of them, the other two will be trivial. This is really the same question 3 times. Okay? But that's all the hint I'll give you for right now. All right, so let's talk about plus plus and minus minus. Actually, just before I do anything else, let me just give you a quick example here. So that is to say, HELLO, when we do remove vowels, should be HLL. Remove consonants should be EO. Remove numbers. This is so let's we'll throw a couple of ones in there. Good enough. So that'll remove digits, the numbers. 1 1 gets removed, so we just are left with EO. Make sense what you're asked to do there?
You still have consonants.
Oh, thank you. Now, does it make sense? All right, so those will be the 3 methods you'll write for your homework assignment. So now let's talk about plus plus and minus minus. Why does it decide to turn that into a solid bar? Seems stupid. Well, whatever. All right, so if we were to say I plus plus, well, let's start with this. Int I is equal to 0. We could say I is equal to I plus 1, or we could say I plus plus, or we could say plus plus I. All 3 of these ultimately change the value of I to be 1 greater than it used to be. Okay? There's even another one. I plus equals 1. So this guy is shorthand. This guy right here is shorthand for this guy. The advantage of these top 2 is we can do plus 3 or something like that, where the plus plus and minus minus only allow us to increment or decrement by 1. Common thing people try to do if they want I to be greater than, if they want to increment by 2, they would say I plus 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 plus. Okay, that's not going, well, that's more pluses than I meant, but that's not going to fly. Why is it? Because this is how things resolve. I is a variable. I plus plus resolves to a number. I does change, so in this case, if we assume this guy happened first and I started off as a 0, I started off as a 0 and it became a 1. So I is now changed, but this guy boils down to the value 1. That is the literal number 1. So when I throw this extra plus plus on there, it's like me saying 1 plus plus. And what am I trying to do? I'm trying to change the definition of the number 1. We don't really have the power to do that. We can't just decide that the number 1 means something else now. Make sense? We're no longer talking to a variable. We're talking to a literal at that point. That's why the plus 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 doesn't work. Okay, so an important thing here is, so just for the sake of argument right now, let me take this guy out so we don't confuse the issue here. I plus plus and plus plus I are often used completely interchangeably, and most of the time that's perfectly acceptable. But these guys do have different behaviors. So let me show that to you. So let's take this guy out here. Actually, let's just do it in our code up here so we can just see the example. that stuff. We'll go ahead and create I is equal to 0. We'll do a system.out.println I. And I'll go ahead and steal that line so we can do it multiple times. So now if I say I is equal to I plus 1, and then I print out I, it's going to print out a 1, right? Not rocket science. If I say I plus plus, and then I print out an I, it's going to print out a 2. If I say plus plus I, and then I print out an I, it's going to print out a 3. Because we just kept incrementing, right? So there's our 0, 1, 2, 3. As I have it written, it does not matter whether I use the plus plus or the plus plus before, the plus plus after. I use this guy here. They all ultimately are giving me identical results. Where it makes a difference is if I decide to do something like this. So let's just go back to the beginning here. So we're only comparing these two. We view I plus plus as increasing the value of I. So what would you guess our output is going to be here? The guess would be the output should be 1, 1, right? But it's actually 0, 1. When the plus plus comes after, it does the incrementing after it boils down to the current value. If we put the plus plus in front of the I, now this will be 1, 1. So if the plus plus comes before, it increments first, then boils down to the result. If the plus plus comes after, it boils down to the result and then increments. That makes sense? Important concept to understand, but as a rule of thumb, you never, ever, ever, ever have to worry about this. If you just decide whenever you're going to increment, don't do it inside of a print statement or something like that, inside of something that relies on the order of operation. Just always do your plus plus I out here or your I plus plus out here. In this case, it doesn't matter because we're not using the value in real time. We're doing the increment, it just changes. Similarly, decrement, I minus minus, minus minus I, same exact rules except this subtracts 1 from it. All right, so good rule of thumb, specifically for beginning programmers, is never use the plus plus stuff inside of something that's expecting the value right now. Where we'll use it fairly often is in like our for loop. So instead of I is equal to I plus 1, I would say something like I plus plus. Or you can say plus plus I. Those won't make a difference because we're not using the value immediately. Okay, the value changes and then we move on with life. Make some sense? So that's the plus plus stuff. So I'll go ahead and I'll upload this to GitHub and I'll put your homework assignment up. But that's going to be due on Monday. And then what we'll talk about on Monday, I still got a minute left. What we'll talk about on Monday is converting strings to integers. All right, how do we actually do that without using the built-in methods? All right, I will see everybody on Monday.